Alright guys, this is chapter 10 part A. We're going to split chapter 10 in two sections because they're really different sections that we can focus on other parts. So this is periodicity, which is very similar to what we did in chapter 3. So you'll see some very similar aspects and reasoning. So the first thing is a really simple introduction to the structure of the periodic table. Which doesn't really make much sense why it's in chapter 10, but all right, I had to do a room change. So in the father of the periodic table is Dmitry Mendeleev, and he's Russian, obviously. And he ordered the periodic table based on their mass, which then there were some holes in there, and he predicted what these holes would be, which in the future they were true to be. That's why he's called the father of the periodic table. And he placed them elements in the same groups that had similar properties and acted the same and whatnot. Now they're not ordered by mass; they're ordered by atomic number. Generally speaking, they're all going to be increasing based on their mass because of the protons. There are a few things when the mass actually drops a little bit as you go across the periodic table, but all in all, the mass does increase, but it is ordered by the atomic number, which is the number of protons. And we know rows are periods and columns are groups. So it's in the periodic table because you're pretty familiar with that. So periodicity basically is just a recurring pattern on the periodic table, and that's why it's called a periodic table. So the first thing is radius. So as you go across, and they love period 3, ACE Chem, as you go across the periodic table in period 3, the radius is decreasing, which makes sense because the number of protons are increasing, the relative energy level is not, so the outer ring is not increasing. You just have a stronger pull of the electrons. That's why the radius is decreasing. Which I just said. Why it decreases? Because the number of protons is having more attractive force to the valence electrons, pulling them in tighter, and you get a smaller radius. So even though you're increasing the number of electrons, you're still within the same energy level, therefore shielding is not occurring, which generally sometimes can cause the radius to increase, but in this case, there is no shielding, so the radius is going to decrease. Now, things change when you become ions. So you have positive charge ions, your cations, and then you have your negative charge ions, which are your anions. So you can see in this graph, it's decreasing as you go across to reach silicon. Basically, all of them have the same number of electrons from sodium to silicon because they all become the same noble gas. They have all 10 electrons. And you can see it decreasing because the number of protons are increasing, so they're more attractive force. Now, when you add electrons, you're now causing the protons to work harder, which they can't. They're still in the same number of protons, so the radius is going to actually increase compared to its atomic radius. So like phosphorus has a lower radius than phosphorus ion or phosphide. So you can see cations are going to be smaller than their atoms, and they lose electrons. Therefore, they lose their valence shell. So you lose the energy level, more protons, smaller radius. Anions are going to get bigger because they're gaining electrons, but have the same number of protons, so it can't hold on to its electrons as much, so it's going to have a larger radius. So you can see here, as sodium loses its electron, bye-bye sodium electron. Its atomic radius goes from 0.157 nanometers. See, who needs your own sound effects? And I gotta move my camera. And the atomic radius is 0.095. So a huge difference in atomic radius because you're losing that energy level. Here, sulfur has 16 protons, has an atomic radius of 0.104, and it's going to gain 2 electrons, so it goes from 16 electrons to 18 electrons, a charge in -2, and its atomic radius is getting bigger to 0.184. So almost a 0.08 difference, well, it is 0.08 difference between the atomic and the ionic. So here's your first homework assignment on Teams/OneNote. Predict the relative size of the atomic radius of lithium and fluorine. So basically, how is it compared to each other? Which one's going to be bigger? Which one's going to be smaller? And then predict the size compared to its atom and its charge. So lithium atom compared to its lithium ion, oxygen atom to oxygen ion, nitride to nitrogen, and fluorine to fluoride. Okay. So I'd say it's going to be bigger or smaller than its atom, or the ion's going to be bigger or smaller than the atom, so forth. All right, melting point. So melting point deals with the structure of the atom. See, these obviously metals are going to be higher, non-metals are going to be lower. But the uniqueness about melting point comes from silicon and carbon group. They're very high. They're the highest of all. So it's kind of like a TP or a pyramid, where silicon is the highest one, and they all kind of go down from there. So you can notice that aluminum is high, magnesium is a little lower, and sodium is the lowest metal, where phosphorus and sulfur are kind of the same, but it goes up a little bit. We'll get to that why. And then chlorine drops down, and argon's all the way down. So you look at the structures, you have giant metallic for your metals, simple molecular for your nonmetals, and then there's the reason why silicon is higher, because it's giant molecular. So it has covalent bonds, but the structure is very large. So it kind of has kind of both worlds. It's a giant structure like a metal, but has strong covalent bonds within each other because it's 4 valence electrons. Electroconductivity, this one's a no-brainer. Conductivity increases as you increase the C of electrons. So the more valence electrons you have, or the more valence electrons you have, the higher the conductivity for metals. And then they go down from aluminum all the way down to sulfur, which is very non-conductive, and chlorine and argon are gases, so they're not conductive at all. So you can see that how small phosphorus and sulfur is compared to silicon and aluminum and magnesium and sodium. So it's going to increase as you go across to reach aluminum because it has 3 valence electrons. So more C of electrons will cause more conductivity. And the nonmetals aren't going to have any conductivity. All right. So checker number 3, we're going to do this together. Why does sulfur have a lower melting point than silicon? Why does sulfur have a higher melting point than chlorine? And why is magnesium better than phosphorus and sodium? So first question is, why does sulfur have a lower melting point than silicon? So first thing understanding with these questions is understanding what type of atom we have, metal, non-metal, metalloid, what type of structure it has, and what type of forces are they going to have. So comparing 2 atoms, they both are covalent bonds because they're both nonmetals. Silicon is a giant molecular. Sulfur is a simple molecular. So there's a difference right there. So knowing that the structure is different, you can use that as your answer. So silicon has strong covalent bonds due to its giant molecular structure, where sulfur has weak covalent bonds due to its simple molecular structure. So that's why silicon has higher melting point, because strong covalent bonds and giant molecular structure. Why does sulfur have a higher melting point than chlorine? Kind of the same reason. Both are covalent. Oh, sorry, sulfur, not silicon. Sulfur. They both have simple molecular structures. Okay, so this gets where it's difficult. sulfur is solid at room temperature, where chlorine is a gas at room temperature. So this goes back to chapter 4. So you can see why we add this into chapter 4, or at the end of chapter 4. So both are covalent, both are simple structures. Why is sulfur a solid and why is chlorine a gas, basically? So you're looking at intermolecular forces. So sulfur has bonds with 8. So actually 8 atoms around when sulfur forms a molecule. Where chlorine is diatomic, it forms 2 chlorine atoms. So knowing that sulfur is S8 and chlorine is SCl2, sulfur is going to have higher van der Waals forces, more electrons. So more electrons means more van der Waals forces, which causes a stronger hold onto its molecules, which means it's going to have a higher melting point. So more electrons, stronger van der Waals forces, higher melting point. Why is magnesium a better conductor than phosphorus? This one's an easy one. Magnesium is metallic, and phosphorus is covalent bond nonmetal. So phosphorus has no conductivity, barely any, very negligible. So that means magnesium has sea of electrons, where phosphorus doesn't. So magnesium can conduct electricity. Now with sodium only contains 1 valence electron. So the more sea of electrons you have, the stronger the conductivity, higher conductivity. So phosphorus doesn't have any delocalized electrons, so no conductivity. Magnesium contains twice as many delocalized electrons than sodium, therefore higher conductivity. All right, ionization energy. Again, this is a review from part A, chapter 3. So if you need any extra review, you can always go back to that lecture. But remember the dip, magnesium to aluminum, and phosphorus to sulfur. Okay. So energy dips from S to P because of shielding, and it's further away because of increased. So and you have increased shielding. Then you have the dip between 3p electrons and 4 electrons in the P. So that is repulsion. To remember that sulfur has a pair of electrons in one of the p orbitals, so it has a repulsion. Therefore, it's easier to remove. Checkout number 4 is on teams again. You will need your book for page 153. Any questions, let me know. It's a pretty short section because in one we broke it up in 2 parts, and I don't know why I put 1 here, but 1 we broke it up in parts, and 2 it's a review of bonds and properties. So it should be a pretty quick section.